Alright, in this video we are going to tell you pretty much everything you need to know about ionic chemical formulas, naming them, identifying them, anything that you could possibly think of, we are about to dissect in this YouTube video. So, the reason why I neglected to make this video for so long was just because I forgot. I couldn't make this video while I was walking because I need you to see my Chromebook. I need you to see all the work that's on here, or else you won't understand this. So, we first need to talk about a chemical symbol. It's an abbreviation for the name of an element. It's 1, 2, or 3 letters. First letter is always capitalized. The 3 letters you don't really need to know because that's like for the elements like deeper in group 7. We don't really talk about them that much in chemistry, and especially not now. So what is a chemical formula? A representation of the elements that make up a compound. A compound is a combination of 2 or more elements chemically combined in a definite ratio by mass. The difference between this and that, the O capitalization, is because CO with a lowercase o is cobalt. It's a transition metal, whereas CO with a capital O is carbon monoxide. Carbon monoxide is very dangerous. Very dangerous. So you know, you get that like from a I guess like, you know, flame that doesn't have enough oxygen, and then you get carbon monoxide. Carbon monoxide is very dangerous, a very stark difference. And that is why capitalization matters so much. I will warn you, this quiz and this test are going to be brutal. They're going to be graded very meanly, as seeing how, you know, if you make even one tiny mistake with spelling or capitalization or grammar or parentheses or whatnot, you get the whole question wrong. That's 5 points off right there because there's only 20 questions. Mr. Adabug is honestly being a little bit meaner than Naomi was. There's been a lot of lying and yelling to me. I've also been having to deal with putting that aside, but I just kind of realized that the disrespect that she showed today, last straw. It had to be mentioned in my YouTube video. Now, what information is found in a chemical formula? Elements found in each compound and a number of elements in the compound. So in H2SO4, you have 2 hydrogen, 1 sulfur, and 4 oxygen. A subscript is the number to the right and slightly below the chemical symbol. It tells the number of elements present in the compound, and if no subscript is present, it's a 1. A superscript is in number to the right and slightly above the chemical symbol, and it indicates the charge of an ion. If no superscript is present, it is neutral. Coefficients are written in front of the chemical symbol, like 2H2O, that's going to be 2 water molecules. The empirical formula is the representation of the simplest log integer ratio in which atoms combine to form a compound. C6H12O6, which is glucose, CH2O. A molecular formula shows us a total number of elements of each element in one molecule of a substance. So again, glucose, that's C6H12O6. NH3 for ammonia is both an empirical and a molecular formula. C2H4 and C3H6 are different molecular formulas, but they are the same empirical formula, CH2. C4H10O and C4H10O are the same empirical and molecular formulas, but unless you see the structural formula, you won't know that. Because this is butanol and this is diethyl ether. Very different. As you can see in this one is symmetrical, so it's non-polar. This is definitely a polar molecule. And it's because in one of them, the O is in the center, and in the other one is attached to an H. Very different substances. But you won't know that even by looking at the empirical formula. I mean, the molecular formula, much less the empirical one. In CaNO3 you have 1 calcium, 2 nitrogen, and 6 oxygen. And in this compound, you have 6 aluminum, 9 sulfur, 36 oxygen. And in case you're wondering what those parentheses are for, that you use if you have a polyatomic ion and you have more than one of them. Then you need a parentheses. The law of definite composition is that all compounds have the same percent composition. H2O is always going to have 2 to 16 or 1 to 8 hydrogen to oxygen. H2O2 is going to simplify down to H2O, 2 to 32 or 1 to 16. The ratio of the mass of oxygen in each is 8 to 16 or 1 to 2. So if you have compound A is 1.33 grams of oxygen per gram of carbon, whereas B is 2.66 grams of oxygen per gram of carbon, and they have equal number of carbon and oxygen atoms, compound A is going to be carbon monoxide, again, that silent killer. Compound B is going to be carbon dioxide, that greenhouse gas, but it's not as bad. The ratio of oxygen to carbon would be 2 to 1 in compound B. So again, CO, CO2. I don't think we did this. So that's the basics of chemical formulas. Now we have to do naming ionic compounds. And there's one more important thing after this that has to deal with the stock system, and it's with transition metals. So, we'll have to dissect this first, of course. So how do we name formulas? Well, for an ionic compound, it's between a metal and a non-metal. As we know, positive ions is a gain of a... I am really starting to lose it today. Positive ions are a loss of electrons. Negative ions are gains of electrons. The oppositely charged ions are attracted to one another and they join to form a bond. The oxidation state on the periodic table is the number of electrons that are lost, gained, or shared. And in order for a compound to form, the sum of them must be 0. There's going to be a lot of mathy involved in this. Now, in case you're wondering for the nonmetals, you always pick the topmost one. Because, for example, nitrogen, you have -3, -2, -1, +1, +2, +3, +4, +5. Most of the time, it's going to be that -3. The others are there mainly for the sharing of it in covalent molecules. You always go to the top right if it's for an ionic compound, for a nonmetal. So for aluminum sulfur or aluminum sulfide, you need 2 aluminum, 3 sulfur. Now, in order to name them, you copy the name of the metal in a nonmetal. But for the nonmetal, you drop the last syllable and you end "ide." So aluminum sulfide, magnesium fluoride, sodium chloride, calcium bromide, strontium oxide. If it's more than 2 elements, with polyatomic ions, this is where table E is going to come into play, because all the stuff you need to know is on table E. If you have to combine aluminum with sulfite, then you have Als plus 3, SO3 minus 2, so you have Al2, parentheses, SO3, but then it's 3 times over. The crisscross method can be used to calculate the chemical formula. It crisscrosses the charges. They become subscripts, and then you reduce the subscripts if necessary. If the subscript of a polyatomic ion is 2 or more, you place the polyatomic ion, place the subscript outside the parentheses. So this is an example of the crisscross method. I personally don't like it, but it's up to you if you want to use it. You can solve it algebraically. Now for the stock system. This is where things get interesting. And no, the stock system does not involve stocks. Although it'd be kind of cool if it did. But it's how you name a compound that can form more than one ion. It happens when a metal possesses more than one oxidation number. You use Roman numerals. That's usually for transition metals. This is copper chloride. This is copper 1 chloride. This is copper 2 chloride. Because, as you can see for copper, it could be either +1 or +2. And you need to make it clear as to which one it is. So this is iron 2 oxide, iron 3 oxide. Iron 2 oxide is FeO. Iron 2 oxide is Fe2O3. For titanium and bromine, you have titanium 2 bromine, titanium 3 bromine, and titanium 4 bromine. So the TiBr2, TiBr3, or TiBr4. For cobalt and sulfate, you have cobalt 2 sulfate and cobalt 3 sulfate. This is cobalt 2 sulfate, cobalt 3 sulfate. With this, you have to crisscross the oxidation numbers and reduce as necessary, and the Roman numeral represents the charge of the metal. Parentheses for subscript of the polyatomic ion if it's more than one. So that's that, you know. Oh, and by the way, don't be dumb like me and think that phosphate is phosphorus. That's phosphide, not phosphate. So, the traditional system. This is super confusing. And you need to know this for the quiz, but you don't need to actually write it for the quiz. But for the test, you will need to specifically write using the traditional system. And it's terrible. It's the old type of naming system that's used to describe the oxidation number that the element takes. The system uses suffixes, OUS for the lower charge atom and IC for the higher charge atom. It does not tell you the exact oxidation state, so for example, cupric, ferrous, ferric. So you need to know, Cl plus 2 is chromous, Cl plus 3 is chromic, Mn plus 2 is manganese, Mn plus 3 is manganic, Fe plus 2 is ferrous, Fe plus 3 is ferric, Cl plus 2 is cobaltous, Cl plus 3 is cobaltic, Cu plus is cuprous, Cu plus 2 is cupric, Hg2 plus 2 is mercurious, Hg plus 2 is mercuric, Sn plus 2 is stannous, and Sn plus 4 is stannic. It's terrible. And this is just some more algebra relating to it. I'm telling you, the stock system it isn't great on its own, but if you have to know all this Latin stuff, it's terrible. This is honors only though. So if you're in chemistry regents or regular, you do not need to know any of the confusing compounds I just named. But if you're in honors, I would take close notes because that stuff is quite hard. Thank you for watching.